Hello, good morning, students. Today we discuss about the DC circuits. DC circuits. So here, what is meant by circuits? And generally, the circuit is a conducting path through which the current will be flows. So if the current flowing through the circuit is DC, then the circuit is known as DC circuits. So here, circuit is nothing but it is a conducting path. It is a conducting path through which the current will be flows. So generally here the current may be classified into two types. So here the current will be flows. Suppose here the current can be classified into two types. One is the DC current and second one is the AC current. So here the DC current will be flowing through that circuit, then that circuit is known as DC circuit. And suppose the AC current will be flowing through that circuit, then the circuit is known as AC circuit. So here, so this is our first unit, that is DC circuits. So in this DC circuits, we are discussing about the different topics. So like different types of DC network elements and basic circuit elements and different types of sources, Ohm's law and what are the limitations of Ohm's law, and series and parallel circuits. So these are the topics we are discussing in today class, that is in DC circuits. So we are discussing the topics for first one is the network elements and second one is the basic circuit elements and different types of sources. Next one is the Ohm's law and its limitations. And next one is the series and parallel circuit. So we are discussing about these topics, that is network elements, basic circuit elements, types of sources, and Ohm's law and its limitations, series and parallel circuit. So we are discussing about these topics in this class. So once again, first is the DC circuit. This is our first unit. So here circuit is nothing but it is a conducting path through which the electric current will be flows. So here the electric current can be classified into two types. One is the DC current and second one is the AC current. Suppose if the current flowing through the circuit is DC, then it is known as DC circuit, or if the current flowing through a circuit is AC, then it is a AC circuit. So our first unit is DC circuit. So in this DC circuit, we are discussing about the network elements, basic circuit elements, types of sources, Ohm's law and its limitations, and series and parallel circuit. So first one is the network elements. So we are discussing about the network elements, and the network elements of a DC circuit can be classified into different types. That is elements of DC network. Elements of DC network. So here the elements of a DC network can be classified into first one, this is the active elements, and next one is the passive elements, and next one linear elements and non-linear elements. Next one is the unilateral elements bilateral elements, and next one is the lumped elements, and last one is the distributed elements. So here these are the different types of elements of a DC network. So all these are the basic concept of a DC network. So first we clear understanding about all this, then we can go forward. So first one is the active elements. So here the active elements are again classified into two types. One is the voltage source, and second one is the current source. And here the passive elements are again classified into two types. One is the resistance, inductance, and capacitance. So this figure shows the elements of a DC network. So it can be classified into different types. One is the active elements, passive elements, linear elements, non-linear elements, unilateral elements, and bilateral elements, lumped elements, distributed elements. So here first one is the active elements. So what is meant by active elements? So generally the active element is nothing but so the element which supplies electrical energy to the circuit, these are known as active elements. So suppose let us consider we are taking any one of the circuit. Suppose this is the one of the circuit, it is having a resistance R1 and resistance R2 and one more resistance R3, and it is having two sources. So this is the source 2 and this is the source 1. So positive, negative, positive, negative. Suppose we are represented with some E1 and this is with E2. So see here this figure consisting of three resistors R1, R2 and R3 and two battery symbols, that is voltage source E1 and E2. So for this circuit here the resistor R1, R2 and R3 will receive only electrical energy. They do not change, they do not give any electrical energy. But here the voltage source E1 and the voltage source E2 will supply electrical energy to the circuit. So these voltage 1 and voltage 2 are called as active elements. So active elements means the elements which supply electrical energy to the circuit are known as active elements. So here not only the voltage source, in case suppose if you are placing any current source also will supplies electrical energy. So the example for active elements is voltage source and current source. And next one is the passive elements. So passive element is nothing but the elements which receives electrical energy from the circuit. So these are known as passive elements. That means so only here the example for passive elements is resistor, inductor and capacitor. That means this resistor, inductor, capacitor will always receive the electrical energy, but they do not supply any electrical energy to the circuit. Hence these are known as passive elements, and the example for passive elements is RLC, resistor, inductor and capacitor. And next one is the linear elements. So what about linear elements? So linear elements means a linear circuit is one whose parameters do not change with voltage and current. So linear circuit means whose parameters are do not change with voltage and current. So then it is known as a linear elements, and the example for linear elements are resistor and capacitor. What about non-linear elements is just quite opposite to that of linear elements. Linear elements which do not change with voltage and current. And coming to non-linear elements, so a non-linear circuit is one whose parameters are change with voltage and current, whose parameters are change with voltage and current, whose parameters are do not change with voltage and current. So these are known as non-linear elements. And coming to unilateral elements, so in the name itself will describe unilateral elements. So here what is meant by unilateral elements? So a unilateral circuit is one whose parameters are do not change with direction, whose parameters are do not change with direction, are called as unilaterals, do not change with direction, then it is a unilateral elements. And coming to bilateral elements means it is also quite opposite to that of unilateral. In the name itself, bilateral. So that means the bilateral element is one, so whose parameters are changed with respect to direction. So change with respect to direction, then it is called as bilateral elements. And coming to lumped elements, so lumped elements means the elements in which the physical separation is possible, then it is called as lumped elements. And the distributed elements means, so the elements in which the physical separation is not possible, so then it is called as distributed elements. So these are the basic circuit elements. So first one is active elements, that means which are supply electrical energy to the circuit, and the example for active elements is voltage source and current source. And passive elements means which receives the electrical energy from the circuit, and the example for passive elements means resistor, inductor and capacitor. Coming to linear elements which do not change with voltage and current, so then that is a linear elements. Non-linear elements means which are change with voltage and current, then it is a non-linear elements. Coming to unilateral, that means which do not change with direction, and bilateral means which are change with respect to direction. And lumped elements means which are physically separation is not possible, and distributed elements means physically separation is not possible. So these are the different types of elements of a DC network. And next one is the basic circuit elements. So next topic వచ్చేసి that is basic circuit elements. So here the basic circuit elements are mainly classified into three types. One is the resistor, and second one is the inductor, and third one is the capacitor. So here we are discussing about the resistor, inductor and capacitor. So these are the basic circuit elements of a network. So here first one is the resistance. First one is resistance. So here, so let us consider any one of the resistance. So this is the symbol of resistance. So here a resistance R, which is the resistance is represented by R, and some current is flowing through this resistor. Suppose the current flowing through resistor is we are assuming as I. So here the current, as per our assumed direction, see the direction of arrow mark, so our current is flowing in this direction. So that means this is the entering, it is taken as a positive and it is a negative. So here the resistance is nothing but it is the property of the material by which it opposes the flow of current through it. So here the resistance can be represented by R, and it can be measured in ohms. So this is the units for resistance. So it can be represented by R, and it can be measured in ohms, and this is the symbol for ohms. This is the symbol for ohms. So here generally the resistance of the any given material, it depends on the different factors, that is R is equals to rho into L by A. So here the resistance of the given material is depends on the, so here resistivity of the conductor and length of the conductor, and this is the area of cross section. So this is the formula to find the resistance of the given material, rho into L by A. So where rho is the resistivity of the conductor, rho is the resistivity of the conductor, and L is the length of the conductor, and A is the area of cross section, area of cross section of the conductor, area of cross section of the conductor. So this is the formula, R equal to rho into L by A. And second circuit element is the inductance. Second circuit element is the inductance. So see here the inductance. So this is the symbol of inductance. So Here also we are just assuming the current direction. Suppose this is the direction of flow of current, that is current flowing is I. So here also the current is entering in this direction. So this is the entering plus and this is the minus, which is represented by symbol L. So here this is the L and it's the positive and negative current is flowing in this direction. So where it enters, that is the positive plus. So here inductance is L and the current flowing is I. Suppose we are taking the current flowing is suppose I of t. So then the voltage across the inductance is we are assuming suppose V of t. So here current flowing is I of t and the voltage across the inductance is V of t. So in generally here inductance. So what is meant by inductance? So inductance is the element so in which the energy can be stored in the form of electromagnetic fields or electromagnetic waves. Electromagnetic waves. So here the energy can be stored in the form of electromagnetic waves. So here for an inductance, generally for an inductance, the voltage across. So here this is the voltage. So the voltage across it V of t is directly proportional to the rate of change of current flowing through this particular inductance. So that means here the V of t is directly proportional to di of t by dt. So by removing this proportionality, we get some constant, that is V of t is equals to, so inductance L into di of t by dt. So this is the formula for V of t. In case suppose here the current flowing through this circuit I of t. Suppose if already we know the value of I of t, so then suppose if we know the value of V of t, then we need to find the value of I of t. So that is I of t is can be find by 1 by L into integration of minus infinity to t V of t. So this is the formula for current I of t when V of t value is already be known. So this is the second basic circuit element, that is inductance. So inductance is nothing but here the energy can be stored in the form of electromagnetic waves. So for this let us consider this is the one of the inductance. So here the current flowing through inductance is suppose I of t and the voltage across the inductance is V of t. So here for an inductance the voltage across it is proportional to the directly proportional to the current, that is represented by V of t is proportional to di of t by dt. So by removing this proportionality we get a constant, that is V of t is equals to L into di by dt. So in this case if the value of V of t is already known, then we need to find the value of I of t. So the I of t can be find by using formula is 1 by L integration of infinity to t to infinity to t and V of t. So this is the second basic circuit element, that is inductance. And third circuit elements, that is capacitance. Third circuit elements, that is the capacitance. So here the capacitance, let us consider this is the one of the capacitor which is represented by C, and here the current flowing through this capacitor is suppose I of t, and the voltage across this capacitance is suppose we are assuming V of t. So here capacitance is represented by C and it can be measured in microfarads. So before this the inductance can be measured in henries, that is inductance can be represented by L and it can be, so here the inductance can be represented by L and it can be measured in henries, and here capacitance which is represented by C and it can be measured in microfarads. So here in the capacitance the energy can be stored in the form of electrostatic field. So in this capacitance the energy can be stored in the form of electrostatic field. So here we need to find the current equations and voltage equations. So here the current flowing through this circuit, that is I of t. So I of t is proportional to the dV of t by dt. So here also by removing this proportionality we get a constant, that is I of t is equals to capacitance C into dv of t by dt. So this is the formula for current I of t in capacitance. So these are the different types of basic circuit elements. So the basic circuit elements are nothing but, so it can be classified into three types. One is the resistor, inductor and capacitor. First one is the resistor. So this is the symbol of resistor. It can be represented by R and it can be measured in ohms. So in generally the resistance of the any given materials depends on the different factors, that is R equal to rho into L by A, where rho is the resistivity of the conductor and L is the length of the conductor, A is the area of the cross section. And the next second one is the inductance. So inductance is nothing but, here the energy can be stored in the form of electromagnetic waves, and let us consider this is the one of the inductance, and the current flowing through this inductor is suppose I of t, and the voltage across the inductance is V of t. So here the voltage V of t is proportional to the di of t by dt. So then V of t we get L into di of t by dt. And this is the second, and next one is the capacitance. So here capacitance C, current flowing here also I of t, and the voltage across the capacitance is V of t. And in capacitance the energy can be stored in the form of electrostatic field. So here the current flowing through capacitance I of t is proportional to dV of t by dt, and here also by removing this proportionality we get a constant I of t is equals to C into dV of t by dt. So these are the basic circuit elements. And next one is the different types of energy sources. Next topic, different types of energy sources. So generally the energy sources are mainly classified into two types. One is the, here the energy sources are mainly classified into two types. One is the voltage source and second one is the current source. So or before this the energy sources are again so before this we are going to discuss a small, that is the energy sources are classified based on the dependent and independent sources. Dependent sources and independent sources. Two types, one is the dependent source and second one is the independent source. So first we are discussing about the independent sources. So independent sources are again classified into two types, this voltage source and current source. These two are the classifications in independent sources. So independent sources are again classified into two types, one is the voltage source and current source. Here the voltage source are again classified into two types, one is the ideal voltage source, ideal voltage source, and second one is the practical voltage source. Ideal voltage source and practical voltage source. Here also the current source is also classified into two types, one is the ideal current source and second one is the practical current source. Okay, so this is the energy sources, and initially the energy sources are mainly classified into two types, one is the dependent sources and second one is the independent sources. So here the independent sources are again classified into two types, one is the voltage source and second one is the current source. So here the voltage source are again classified into two types, one is the ideal voltage source and practical voltage source, and current sources are again classified into two types, one is the ideal current source and second one is the practical current source. So first one coming to this voltage source. In voltage source first we are discussing about the ideal voltage source. So here what is mean by ideal voltage source? Generally the ideal voltage source is nothing but, it can be defined as the energy source which gives constant voltage across its terminal irrespective of the current flowing through that circuit. So here ideal voltage source is nothing but, so which gives constant voltage, which gives constant voltage across its terminals irrespective of the current flowing through that circuit. And here how can we represent this ideal voltage source? The ideal voltage source can be represented by like a symbol. So this is the positive and negative. So this is the symbol of ideal voltage source. So how can we represent the practical voltage source? So here ideal voltage source is nothing but it can be represent a constant voltage across its terminal irrespective of the current. But for practical voltage source, in generally every practical voltage source has a small internal resistance which is in series with the voltage source. So this is the symbol for voltage. So practical voltage source, it is having a small internal resistance which is connected in series with the voltage source. Here this is a resistance, series resist or SE, series resistance which is connected in series with the voltage source. So this is the symbol for ideal voltage source. This is the symbol for ideal voltage source, and this is the symbol for practical voltage source. And coming to the current sources, so current sources are also again classified into two types. One is the ideal current source and second one is the practical current source. So first coming to the ideal current source. So what is mean by ideal current source? So generally the ideal current source is the source which gives constant current, which gives constant current at its terminals irrespective of the voltage flowing through the circuit. So that is called as ideal current source. And coming to the practical current source, here also the practical current source is having a small internal resistance which is in parallel with the current source. So we can see the diagrams for ideal voltage source and practical voltage source. So generally the ideal current source can be represented by like this. So this is the symbol of current source. So it is the ideal current source. And for practical current source, it is having a small internal resistance which is connected in parallel. So this is the symbol of current source. Again here the resistance should be connected in parallel with the current source. So these are the terminals. So this is the symbol resistor, and here the current source. Here also this is the current source. So this is the symbol of practical ideal current source, and this is the symbol of practical current source. So these are the classifications in dependent sources, independent sources. So independent sources are two types: voltage source, current source. Voltage source again classified into two. One is the ideal voltage source, practical voltage source. Again current sources are also two types: ideal current source and practical current source. So these two are the symbols of the ideal voltage source and practical voltage source, and these two are the symbols of the uh, ideal current source and practical current source. And next coming to the discuss about the all these are the independent sources. Then what about dependent sources? So the dependent sources are again classified into four types. The dependent sources are again classified into four types, and these dependent sources can be represented by diamond shape. Dependent sources, so these are the four types, and these dependent sources are represented by diamond shape. So what are the different types of dependent sources? We are already discussed about the four types. So what are the different four types of dependent sources? So that is, first one is the voltage dependent voltage source. Voltage dependent voltage source. And second one is the current dependent current source. And third one is the voltage dependent current source. And fourth one is the current dependent voltage source. So these are the four types in dependent sources: voltage dependent voltage source, current dependent current source, voltage dependent current source, and last one is the current dependent voltage source. We have to represent these dependent sources in diamond shape. So how can we represent the first one, that is the voltage dependent voltage source? So the voltage dependent voltage source can be represented by like this. So here we can represent with a diamond shape. So these two are the end terminals. So here first one is the voltage dependent voltage source. That means V is equals to K into voltage dependent voltage source. V is equals to K into V1. So just wait. So V is equals to K into V1. So that means voltage dependent voltage source. So it is the plus and minus. So this is the symbol of first one, that is voltage dependent voltage source. And next one is the second one is a current dependent current source. So how we can represent the second one, current dependent current source? So here also the same, the small change. So this is the diamond shape again. So these are the end terminals. So positive, negative, and it is a current dependent current source. That means it can be written as I is equals to K into I1. So that means current dependent current source. So this is the symbol of current dependent current source. And next third one is the voltage dependent current source. Voltage dependent current source. So voltage dependent current source can be represented like this. So plus minus, and this is the two ends. So here this is the voltage dependent current source. That means I is equals to K into V1. That means voltage dependent current source. So this is the symbol for that. And last one is the current dependent voltage source. So current dependent voltage source is also represented like this. So this is the diamond shape, and these are the end terminals. So plus minus. So here current dependent voltage source V is equals to K into I1. So these are the symbols for different dependent sources. So here the dependent sources are classified into four types: voltage dependent voltage source, current dependent current source, voltage dependent current source, and current dependent voltage source. And these are the symbols for different types of sources in dependent sources. Okay, thank you. So remaining classes we are discussing in the next video.